It's going to take a long time for the sun to die. When it runs out of hydrogen, it will slowly expand, becoming a red giant, and then rapidly shrink into a white dwarf, the remains of a dead star. Not all stars are destined for this slow decline, however. If a star is massive enough, it will erupt in a supernova, an enormous and colorful explosion. The star's core will collapse, and one of three things will follow. Everything will be destroyed, leaving a vivid nebula visible from Earth. A black hole will be created, or a neutron star will be created. Supernovas are so bright that they were witnessed from Earth long before we knew what they were or had telescopes to see them closely, though visible supernovae are still relatively rare when compared with the lifetime of a human. Plenty of people will never see a supernova in the sky during their lives with the naked eye, though we have lots of images of them and the nebulas they leave behind. But supernovae can happen so close to Earth that astronomers have built a supernova early warning system, or SNOOZE, capable of detecting one via neutrinos. This isn't to evacuate the planet, however, it's just so that scientists can be sure they're watching when it happens. Supernovae are always dramatic, but some are definitely more dramatic than others, and a hypernova is one such event. A hypernova is an even more violent incident, so extreme that it's also known as a collapsar. A star with sufficient mass will sometimes collapse with so much energy that a rapidly rotating black hole is created, surrounded by an enormous accretion disk made of all the material ejected in the explosion. After this, the black hole will emit not one plasma jet, but two of them, making it an exceptionally bright object releasing immense energy and radiation. These plasma jets, technically called astrophysical jets, emit ludicrously hot matter at almost the speed of light. They can be pretty common around dense objects like black holes and neutron stars that have a habit of developing large accretion disks, which is a large amount of dust and debris that gets superheated as it swirls around a gravitationally powerful body. But despite their prevalence, they're still extremely weird. We don't entirely know how plasma jets get made, only that they do, and they're a major part of life in outer space. A hypernova is also significantly more energetic and brighter than a typical supernova, and can happen in stars with masses of 30 solar masses or greater. They're so powerful that they're capable of fusing very heavy metals. Scientists have discovered weird stars with a quantity of heavier metals that could only have been created through this kind of an explosion. We've even found evidence of a primordial hypernova in 2021, one that happened when the universe was barely a billion years old, right on the edge of our galaxy. There are other strange types of supernovae as well, like kilonova, which happens when two gravitationally compact objects, like neutron stars or a neutron star in a black hole, collide. Like hypernovae, kilonovae produce gamma-ray bursts. These are radioactive blasts that for a long time remained mysterious. Scientists have spent decades trying to find the sources of gamma-ray bursts after they were discovered accidentally by Cold War satellites looking for nuclear bombs. Fortunately, these gamma-ray sources are extremely far away, billions of light years in fact. But what if there was a catastrophic explosion like this much closer to home, like right in the heart of the Milky Way? Remarkably, just 3.5 million years ago, there was a vast explosion in the center of the Milky Way, although it wasn't a hypernova. This was so recent that some hominids and species that still survive on Earth today might have witnessed it. 3.5 million years ago, Earth was still in the same geological era we're in today, the Cenozoic era, which began after the dinosaurs were wiped out. The only major differences were that Homo sapiens hadn't evolved yet, and the planet was a few degrees warmer. Clearly, this explosion didn't have much of an effect on Earth, since we're here. But what was it? Well, it was actually a phenomenon called a Seyfert flare, something that generally happens in the center of a Seyfert galaxy, which the Milky Way is not. A Seyfert galaxy is a type of active galaxy, a galaxy in which the supermassive black hole at the center is actively consuming matter. The other class of active galaxy is a quasar. Quasars are the most luminous objects in the universe. Just like hypernovae, they produce an enormous plasma jet. Unlike these galaxies, though, the Milky Way's black hole, Sagittarius A star, isn't currently consuming any matter. If it was, we'd see it, because it would be extremely bright. What the existence of the Seyfert flare in the Milky Way's very recent past means is that the Milky Way was active at that time. Since the Milky Way is almost as old as the universe itself, It would actually be weirder if it had never had an active galactic nucleus of any kind. Scientists believe that a huge cloud of hydrogen fell into material circling Sagittarius A star, causing the explosion. The explosion tore through the Milky Way and two of its smaller satellite galaxies, leaving a trail we can still see today. On this basis, it's safe to say that a hypernova explosion, even as close to us as the center of the galaxy, would be little more than an incredible light show to us here on Earth. Supernovae are already some of the most beautiful and destructive things that exist anywhere in the universe, and the same would be true if one occurred right in the middle of the galaxy. The Seyfert flare was even supposedly visible for a whopping 300,000 years, meaning that many generations would have been born and died underneath a sky illuminated by a hypernova. But is it even possible that a hypernova specifically would occur in the galactic center? It could, but the source wouldn't be Sagittarius A star. That's because as powerful as Sagittarius A star is, with a mass of 4 million times greater than the Sun, it's not a star anymore. We don't entirely know at the moment how black holes die, but leading theories say that they leak radiation, called Hawking radiation, and eventually shrink and disappear. This is far from the dramatic explosion that comes at the end of a star's life. Scientists are also still researching whether or not stars can form in the center of a galaxy, or whether the close proximity to the supermassive black hole prevents them from doing so. If stars can form there, which some research does support, then there's no real reason why one of them with enough mass couldn't eventually hypernova. But this explosion still wouldn't affect us here on Earth, and with so much already going on at the center of the galaxy, we might not even be able to see it. Still, a bright enough flare or jet would still be visible far beyond the boundaries of the galactic center, and a hypernova could occur anywhere in the galaxy, potentially far closer to Earth than the center, just like the one found on the edge of the Milky Way. This star was only 7,500 light-years away from the Sun, while the center of the galaxy is 26,000 light-years away. Even an awesome hypernova so much closer still didn't cause any harm on Earth. The closer a hypernova is, the more likely we'll actually be able to see it from our pale blue dot. And all the more extraordinary its jets will appear, but it's not going to do us any damage. If there was a hypernova in the heart of the Milky Way, the best we could hope for is that it's a tremendous display of the beauty of the cosmos, while at worst, we simply wouldn't be able to see it at all. And that's what would happen if the galactic center went hypernova.